What about thermit welding of rails? Rail gaps of fishplate joints in track have to be welded quickly and safely. The code of practice describes the steps of working procedure in detail. What about thermit welding of rails? Rail gaps of fishplate joints in track have to be welded quickly and safely. The code of practice describes the steps of working procedure in detail. The needed equipment and consumables are also included. The code of practice won't do only to be read. You have to undergo training and to pass a practical examination to get a certificate of your successful passing. Rails. What does that mean and include? Vignal rails, or grooved rails, or crane rails are jointly to be welded. Rails of the same type but of different profile can be welded too. Such are rails of the same type and same profile but different worn. Rails of different types, for example, Vignal rails with grooved rails, can also be connected by thermit welding. It is also possible to remove defects in rail heads and repair them by special thermit welding. Rails don't only differ in outer shape, the rail profile, but also in their material properties, the rail grade. Rolling marks show the rail profile and the rail grade. Both aspects have to be matched then with the labelling of the selected welding portion. Which consumables and equipment are needed? First, a reaction crucible. Independent of welding process, different crucible systems are in use, either single-use crucible, one crucible for one weld, or long-life crucible, one crucible for several welds. Uncharged, single-use crucible, 1-inch high design, with large cap for gap 75, with small cap for gap 50. Uncharged, single-use crucible 1, with large cap for gap 50. For standard gaps, either the uncharged single-use crucible 1-inch, or charged, or the single-use crucible 2-inch charged. The long-life crucible system can be used at all gap widths. Maybe a high extension ring becomes necessary. Furthermore, moulds are required. For each weld, one set of moulds is needed. These may differ depending on their appliance. 2-part moulds for Vignal rails, here for luting by paste. 2-part moulds for Vignal rails, here for luting by sand. 2-part moulds for grooved rails. 3-part moulds for Vignal rails. 3-part moulds for grooved rails, as well as 3-part moulds for crane rails. With the aid of these moulds, in each case, they connect the same rail profiles. As already mentioned, different rail profiles can be welded too. These moulds are designed as 2-part or 3-part versions as well. By means of a chemical reaction, the thermit portion produces liquid steel. The thermit portion has to be selected with the help of its labelling, under the aspect of rail profile, under the aspect of rail grade, under the aspect of the used welding process, under the aspect of the selected crucible system. To avoid a split leakage of liquid steel between mould and rail, the area around has to be sealed either by using luting sand or by using of luting paste. At 1000 degrees Celsius, a lighted igniter starts the thermit reaction. Igniters have to be stored separately from thermit portions. Don't carry igniters in clothes near your body. The tapping thimble on the bottom of the crucible melts through after a defined time, so tapping automatically goes on. Here the tapping thimble which is set into the long-life crucible, and here the tapping thimble already integrated in the single-use crucible. The required preheating flame may be produced either by oxygen or propane, or by oxygen and acetylene, or by suctioned air and propane, or by compressed air and propane, or by compressed air and gasoline. Of course, all consumables can process to a correct thermit weld only by using correct welding equipment. Here also it is essential. Good work is possible only with proper and complete tools. Let's start. The first step of thermit welding is to create the welding gap. This gap shall be straight and at right angles at all sides. The allowances for gap widths shall be kept. The preparation of the welding gap can be done in different ways. By disc cutting, as shown here, or by flame cutting. Gap width is to be marked for the purpose of cut. As a guidance for the cutting torch, the cutting gauge is always to be set onto this rail, which has to be cut. To light the torch, first open the oxygen valve at the handle fully, and afterwards the combustion valve only a little bit. Whilst valve for oxycut is fully opened, the combustion valve is closed step by step until the circular heating flame is sharply shaped. Now the valve for oxycut is to be closed. The cutting torch is to be set onto the rail foot. The foot edge is to be heated up to the melting temperature, and then the valve is oxycut to be opened. The steel burns to slag, which is blown out of the cutted gap. The cutting occurs in 3 steps. Starting at the foot, the torch is to be let over the web up to under the rail head. Then the reverse foot, and finally the rail head must be cut. Now slag residues have to be removed. Pulling the rails can also be used for the preparation of the welding gap. After creating the gap, the alignment of the rails follows. First, alignment of sides. Outer edges of rail feet shall run in even line to each other. Mismatch is not allowed. As well, the straight edge shall fit along both running flanks with no split. Afterwards, the adjustment of crown. Whilst cooling down, the welded joint shrinks downwards. To counteract this movement, both rail ends have to be somewhat reinforced before welding. The amount of crown given in Code of Practice is only a reference value for it. Influences on amount of vertical shrinkage are gap width, height of rail head, height of rail web, as well as the track conditions. These influences have to be considered when current crown is to set. The correct preheating torch is to be selected. On each torch is apparently marked by which gases and which working pressures it shall work. Stamped number at torch head shows the torch type. In Code of Practice, you can see which torch type is to be used for which welding process. The clamping device is to be fastened at the rail head without canting at the distance to the welding gap specified by the setting gauge. Still, before the later setting of moulds, the preheating torch with the burner saddle is to be adjusted over the gap. For this, you must first set the correct torch height. By using the setting gauge, that means the distance of torch to the running surface. For the purpose of uniformly covering of both rail cross section areas by the flame, then the preheating torch, inserted into the burner saddle, is carefully to be set both centrally to the gap and at right angle at all rail axes. As from now, the correct positioned torch must not be disconnected from the burner saddle, but only together with the burner saddle you can remove it now from the clamping device. Due to the different milling tolerances of the rails, it may become necessary to renew the correct fitting of mould to rail, done by careful rasping. If a rework of moulds by filing is required, the collar geometry must always be kept. If it's impossible to comply with this, then use special transition moulds. The moulds are to insert into the mould shoes and then to set to the rails one by one, but not at the same time. Both mould halves should be perpendicular to the rail and centrally to the welding gap. Set second the mould half against it and tight slightly the toggle screws onto both mould shoes. Both mould halves must fit together at the rail head and rail foot without mismatch. Check with your finger at the inside of the mould head as well as at the outside of the rail foot. Analogously, go on with the three-part moulds. Both mould halves must fit to each other without mismatch, as well as the mould halves to the underfoot plate. Check the seat of the plug by inserting into the moulds as a trial. When welded in curves, the rails are canted. The steel shall pour equably over both plug ends into the moulds. Thus the top surface of the mould plug must be filed to ensure that it is horizontal when fitted into the mould. For sealing, the moulds optionally either luting sand or luting paste are available. Luting sand shall not be too dry or too moist. It should be well kneadable. During luting the mould at the rail head, there are always used cardboards. These will burn later and create a split, which liquid steel will fill up. The dimensions and the utilization of the cardboards differ depending on the processes. In some processes, a spattle becomes necessary for luting the railhead. In this case, firstly push a little bit of sand through up to the spattle and compact it. Now fill up further sand and compact it. The pouring liquid steel shall meet a compact sand barrier inside, under the mould head. If differently worn rails are to be welded, then spaces unavoidably will occur between the mould and the rail under the foot and head of the more worn rail. These spaces must be filled with cardboards, while the cardboard's corking mustn't project beyond the mould surface. As you already know, the principle from luting at the railhead here, the luting sand is also to be pushed against, and this way to create the compact sand barrier for the liquid steel. By lack of these cardboards, the sand would acceptably be pushed through the space inside the moulds, and would result in sand inclusions in the weld. Whilst luting is to foreclose any falling of sand into the moulds, sand inclusions in the weld would be the result. Luting material is to fill up to the outer edge of the mould shoe, then to press on and all around carefully to compact. Work accurately and don't forget any place, otherwise the liquid steel will leak out there later. After sealing, the rail heads left and right of the joint are to be protected. If hot welding sparks meet the cold rail head, then a fatigue fracture may develop on these points. They're to set only whilst the flame is burning. At site, the gas is to extract from cylinders. When the gas extraction takes longer, then the cylinder pressure decreases. In consequence of the working principle of the reductor, the working pressure inside the hose likely increases. Thus, the working pressures shall be kept constant during the whole preheating by regulating the reductors to avoid any subtly uprising of oxygen excess in the preheating flame. Up in the crucible. After the segregation of steel and slag, the thimble melts through. First the steel pours in, then the slag follows and fills the slag pans. Once again, the pouring is shown as a simulation. First close the combustion valve and then the oxygen valve. Whilst an improper flashback of the flame into the torch happens, the oxygen valve as well as the combustion valve shall quickly be closed. Moist slag pans are to be dried to avoid a dangerous creation of detonating oxyhydrogen gas during the later slag running in. The burner saddle with inserted torch is set up. Then it shall be fixed and adjusted. The oxygen valve on the handle shall fully be opened. Now, by slightly opening the combustion valve on the handle, install a combustion excess in the flame. The torch flame develops a rattling noise. Then close the combustion valve at the handle so far only until this rattling noise just disappears. Therefore, an improper oxygen excess is excluded in the flame. The preheating runs by neutral flame. Both flame cores over the molds should have the same length as well as the correct height. Only now starts the preheating time given in Code of Practice. The simulation shows how to heat up both rail ends. The lighter the color, the poured liquid steel cools down and solidifies slowly. The appropriate form design of the casting mold determines the three-dimensional cooling and solidifying procedure. The result is a weld material without inner failures and with requested properties. The empty crucible and the slag pans are to be removed and to place on dry and non-flammable ground. Attention! If hot slag contacts moisture, then oxyhydrogen gas explosively generates. Danger of accident. The protection of the rail heads is taken off. Now the clamping device and then the mold shoes are to be removed carefully. A specified waiting time after pouring should be kept for this. Predetermined breaking points on the molds are to be created. After another waiting time after pouring, the mold head including the slag is put off. The running surface is to be cleaned of all residues. A hydraulic trimmer is used to cut the excess metal from the weld. The cutting height over the running surface is limited due to the down holders. If the mold head is removed early, the welding material is colored white or light yellow. Start the trimming when a darkening by oxide skin with blisters rises up. If the mold head is removed later, the welding material is already colored yellow. Then immediately start the trimming. The given waiting times after pouring to the mold head removal and to the beginning of trimming may be only rough recommendations. Influences on the waiting times are the rail temperature, the used crucible system, the gap width, a different wear of the rail head, the matched preheating gases, an incorrectly set flame with oxygen excess and incorrect preheating time, an incorrect preheating time, as well as specific portion grades. All these facts will be imparted during the welder's training. The cooling down rate shall not be too high because of its influence on the welding material's properties. Therefore, it is necessary to cover the weld during rain and wind to defend it from quick cooling. The rails get shorter at decreasing temperatures, so unacceptable tension forces appear onto the solidifying welding material. To counteract this unacceptable rail movement caused by shortening at decreasing temperatures, either you heat the rails or you hold the rails by hydraulic puller devices. The residual welding material on the running surface and on running flank will be grinded off. The shrinkage downwards is finished not before the ambient temperature is reached. Therefore, a small oversize has to remain after rough grinding. In case of reassembled and tightened fasteners, the weld could now be passed by a running wheel. Only when the weld is completely cold can you remove the mold residues and knock off the risers at the rail foot. The shrinkage is finished and the fasteners are reassembled and tightened. Only now the final fine grinding has to be executed. By means of fine grinding, the rail head profile at the running surface, at the head radius, and at the running flank is to be restored. The compliance with the demanded tolerance is normally checked by the 1 meter straight edge and by the filler gauges at the running flank and at the running surface. the weld is to be marked. And this way, a complete thermit weld looks at a Vignal rail, at a grooved rail, or at a crane rail.